problem is to find the cube root of a number. To solve this problem, we are going to use the Newton-Raphson's method of finding roots of an equation. The method can be provided with any equation and it finds out any root of that equation. So for our problem, we will provide the the algorithm with a cubic equation. By cubic equation, let's see. If we say that n is any number that is a cube of x, so we can write something like this. So the x will become the cube root, and if we formulate this equation in this form and solve this, so on solving this we will find x, that is a cube. So this will be the input to the algorithm. Okay, let's see the algorithm. Here is the algorithm. We are reading three values. X0 is the initial guess for the cube root. N is the number of iterations we have to perform. The problem with this algorithm is that it is not necessarily converging. That is, if we do not get some appropriate initial value, then it may diverge in that conditions. So we need to provide some bounds so that the algorithm can stop in such conditions. Epsilon is the minimum error, that is the minimum difference of two values. This is used to find out whether we are converging or not. Okay, now the next step is 2. For n iterations, what we are going to do is find out the value of function at x0, that is initial guess. The function is the cubic function which we provided in the procedure. After that, calculate the differential. Differential is used in the formula, so we will need to provide the algorithm with the differential equation. As for this equation, here is the differential equation. So we are finding the differential function value of x0 also, and the next step is the formula. In this formula, a next prediction for x is assigned to the initial minus the division of the function value and the differential function value. After that, we are having two values of x, the initial and the current one. We are going to get the difference of them and check with the epsilon, that is the minimum error provided. If it is less than epsilon, then that means that we have converged appropriately. So we will going to take the step 12 and write convergent solution as x1, that is the current value, the value of function at x1 and the iteration in which we found that value. Else, if we do not converge, then we are going to assign x0, that is the initial, the current value, and again proceed with the iteration. As following this procedure, at some point we will appropriately converge and finally have some answer. Else the situation can be also that if we do not converge at all, we can't find any answer and iterations over. So in that case, what we are going to do is write do not converge in n iteration, and the function values, differential values, initial value and the final value at that iteration or the final iteration. So it is the algorithm used by Newton-Raphson method to find roots of an equation, and we can easily use this to find cube root. We can also use this for finding square root. We can try for that. Let's see the program for this. Here is the program for the algorithm we saw. I have written the program so specific so that I can find the cube root. So I have defined some constant function like this. The one returns the cubic function value at x. Second is the differential function value at x. Now let's see the main function. Here n is the input value from in which we can provide a number for which we want to find the cube root. x0 is initial guess, e is the minimum error, n is the number of iterations. Firstly, we are printing all the values, then moving with the iterations, assigning fx0 to the function value of x0, the differential function value of x0, finally the formula, and finding x1. After that, taking the absolute difference of both values and checking with the minimum error. If it is less than this, then print the root as x1 and break. That will stop the program. Else, we are going to write all the values and proceed with assignment of x1 to x0. Again continuing with the loop. So following this procedure, at some step we may converge and finally print out that root value. Else it may happen that all the iterations are over and we have not found the root appropriate value. So the else statement will execute if the root for loop is ended without the break statement, then it will print could not find the cube root, try with some another initial value. We can provide with the message also. So it is very efficient algorithm to solve our problem, but the only problem is that with the initial guess, if that is not correct, it may diverge, it may not find any value. So we should take care of that we give some initial value as a appropriate guess, so that it can converge and find out the root value for us.